This is the LV5048 inverter. It's a relatively new model from MPP Solar. This one belongs to a friend of mine, but he's letting me test it out before he installs it at his house. So we're gonna get to see what it can do. That new inverter belongs to my friend Bill, and so do these batteries in this rack here. So I'm going to be taking these out of my larger system so that I can hook them directly up to the inverter. That way we can test the inverter together. All of these are going to be leaving my garage shortly and going up to his house, so this is kind of our last chance to test it. By the way, for any of you who are interested in how my racks are doing, I've been very slowly charging and discharging them. I have noticed a couple of weak cells, so I want to focus on them directly. But things are taking a while because it's just a lot of capacity and I'm doing very low amps. So please be patient with me while I work on these guys. But in the meantime, let's get my buddy Bill's rack disconnected from my larger pack, and then we'll connect it up just to his new inverter. Underneath there's a couple of screws to screw it to the bracket. And everything lines up. I don't have to bend some metal to get it to fit. It arrived in great condition. This model is called the LV5048. It's a 48 volt DC and it is 5,000 watts total. But it actually has two legs at 120 volts and they are 180 degrees out of phase from each other. So we can get our standard North American power of 120 and 240 out of the same inverter. Now it's pretty obvious when you look inside that each side is its own inverter. This is two separate inverters. So each inverter is going to be a 2500 watt, 120 volt. Also, there's a paralleling chip already installed from the factory. So if you want to up this, you can parallel more of these together to get 10,000 or 15,000 watts. Each one has its own MPPT input, which means that you can combine two separate solar strings or solar arrays up to 150 volts DC into each side, and each one will individually track the maximum power point. That's MPPT, maximum power point tracking. It's kind of like getting all this stuff wrapped into one, so I'm excited. Now my buddy did buy this and it's $1,400, and so I am not going to kill it. But I do want to ensure that it can do surges because he is planning on installing this on his 240 volt well pump. When he loses power up in the Vermont mountains, he loses his well, and his water is the big thing. He has a wood stove so he can still keep his house heated, but if he loses water pressure, that's a problem. So he really wants a backup system for the well. It looks like these are 13 millimeter. Let's get these out of here. Now I'm only going to have this up for a day. Here's where the main positive and negative wires come up. These are 5/16 inch lugs on 2/0 cable. If we look up inside here, we can actually clearly see there's a positive and negative that goes up into the inverter directly above us, and then there's a positive and negative wire that travel left and over to another set on the second inverter. So it's pretty obvious right there. One of these boards allows you to connect it to more down the line. And I don't know, this one here. It says parallel connection. So this is your AC input and AC output. If I remember correctly, this cannot backfeed the grid, but you can have an input from like a generator and then output to a critical loads panel. I think he's doing something like that. I think my buddy's going to use the grid as his backup for the input, and then the output is going to feed a critical loads panel. Up over here we can see PV1 and PV2, positive, negative, and and then inside we can actually see the wires come over to the left and right inverter from here. So this solar array is moving to this inverter. This solar array goes to this one. I'm about to make the negative connection, and I've already made the positive connection below us. So this is the final connection to send power to the inverter. I've double checked that the inverter switch is off. Now when I make this connection, I like to use a little resistor first. So I'm just going to put the resistor on the post and touch the resistor. Okay, at the inverter there's a switch under here, so let's go ahead and switch it on and see what happens. And they're starting to boot up. Let's take a look at the screen. This is the initial startup. I haven't adjusted anything yet. I haven't touched any buttons. Let's go ahead and see how much current it's drawing. We're currently drawing 1.4 amps. We're at 53.2, 53.19. Check our AC output and see if we can get that 120/240. So neutral to line 1, 120. Neutral to line 2, 120. And it's like 120 exact. All right, now let's go between L1 and L2. No, we're not getting it. Nope, I'm not getting the voltage reading on L1 and L2 to 240. I'm going to turn off the camera and play with some settings, and then we'll catch back when I know what I'm looking at. Okay, well, I was reading through the manual that I printed out because it didn't come with one, and it says that I can adjust this while it's in off status. So I need to turn it off first. Okay, so I'll turn it off. I need to press and hold enter. And this is item number 28. Okay. And right now it's on 2A0. It needs to be on 2A2. And now it's on 2A2. Okay, great. Now I think I can turn it back on. So neutral to L1 is 120. Neutral to L2 is 120. And let's go L1 to L2. 240. Excellent. All right, so that worked. So it was item number 28 in the menu. And we were able to adjust that. And now we have 120 and 240 output. Awesome. I'm hooking up a temporary electrical box to the temporary inverter in a temporary fashion. I'm stressing that because, you know, I don't have a conduit connecting between the two, and I wouldn't mount this on the battery rack if it was permanent, but I'm only testing it for a day before my buddy's taking it back, so I gotta do something quickly. This is the general layout of how my buddy's going to be setting up his system. He's going to have the batteries to the left of the inverter, then he'll have the inverter. In between here, he is going to have a Midnight Solar mini DC disconnect box. It's very similar to the one that I have on my Victron charge controller, and he's going to have that in between here with a 175 amp breaker. Now I have two outlets wired to two separate circuit breakers. Each outlet is a 20 amp, and so I have 20 amp circuit breakers wired to these guys. And I have one labeled A and B. That's just indicating the two separate phases. And this inverter is putting out two separate phases, split phase electricity. So I also wired in at the very bottom, I think it's below the screen right now, is a 240 volt outlet so that I can try plugging in a 240 volt load and make sure that it can do that as well. Alright, we can go ahead and I'm going to throw on the circuit breaker that will then deliver power to the circuit breaker box. That's right there. So now we can start plugging some stuff in. Let's go ahead and start off with this. This is just a space heater. It draws about 1500 watts on high. Okay, so as soon as this kicked on, I actually heard the inverter's fan turn on as well. I'm going to set this down, we'll check the amps. Alright, so we have 12.5 amps on red. It should be a maximum of 2500 watts. I don't think the two sides of the inverter can do sharing, but we're going to test that. Now I currently have a 12.4 amp draw on one leg. Now this shop vac can drop to 11 amps, so I'm going to turn the shop vac on and see what happens to this one leg. Okay. And then it settled out at 22.6 amps, which should have overloaded that one side, but it actually handled it, and our amps are currently showing 0. Now I do have this big bad boy space heater. This is a 240 volt, I think it was a 4500 watt. Let's see, 4800 watt. So this is a 5000 watt inverter, and this is a 4800 watt heater. Yeah, so right away I heard the fan on. Currently with this big space heater plugged in, that one's off. We are drawing 19.8 amps on that phase, and let's check the other phase, the other leg, 19.8. So we're drawing equally on both. It says our battery voltage is currently 51.6 and 95 amps. 92% load, and it says 2.3 kilowatts, but that is on B. Now it's on 1, 2.27. So it's actually showing us the two different inverters, the two different sides right now. Alright, the space heater is running below me. We're at 92% of the inverter's output, and I'm going to go ahead and turn on this other space heater, which should definitely throw us into an overload. And so let's see how it shuts itself off. Now it's currently beeping that it's overloaded. Alright. So it shut itself off safely, and I don't think it blew anything up. For the next test, we're going to have the shop vac, space heater, and the miter saw, and I'm going to run it through this big chunk of oak. So this is a pretty big beefy chunk of oak here. Now the space heater is going to be on one phase, the shop vac and the miter saw are going to be on a second phase. We have the miter saw and the shop vac on this phase, and up here this is just the space heater. And we're going to be checking it and see how it goes. So we got to turn this back on because last time it was in fault, and it's going to go through its check. So there's a really high surge with this motor. So we'll find out what happens. The vacuum doesn't have too high a surge, but it does have some. But we'll turn the vacuum on first, which is how I would normally operate. Then we'll turn the saw on. I'll give it a sec to spin up, and then we'll start plunging it through this piece of oak. Okay, now I love this test because this miter saw actually killed some inverters in some past videos. So I know it has a really high surge. Darn! So with the vacuum and then trying to start the miter saw, that was too much on half of the inverter. Now we'll try the same test, but this time around I'm going to turn off the space heater. So the only things will be the shop vac and the miter saw, but I will leave them on the same phase to see if it overloads that phase again. Oh, yep, it did overload that phase. So we know for sure that it cannot do 100% sharing between the two halves of the inverter. So half the inverter is really on just one phase, half the inverter is on the other. There is a little bit of surge capacity built in. We saw that when we were putting the shop vac and the heater on one phase, but it's not enough of a surge to be capable of handling both the vacuum and the miter saw on the same phase. But now let's try it using both phases. So the space heater is completely off and disconnected. I moved the shop vac to one of the phases, so the shop vac and the miter saw will be on separate phases. So now let's see if it works. Oh! Darn! I am so disappointed. I was really hoping that was going to work. Oh man! I really wanted to see if this inverter could handle the miter saw, but it did not. We now know what it can power and what it can't power. Can't do the miter saw, which was really disappointing. But I want to see how clean the sine wave is. This is supposed to be pure sine wave. So I've hooked up the oscilloscope. Now I am an amateur at this. I've only practiced with it a couple of times, but I've got the probes connected to both phases. So hopefully we'll be able to see both phases coming across the screen. I know when I put my voltmeter on there, we get the 240 volts. So yeah, let's turn this on. I'm going to bring the camera in close to the screen of the oscilloscope, so hopefully we can see it all together. Okay, so we're only seeing one phase right now. That should be 2, and there should be an auto scale here. Whoa, is that what we want? Okay, I'm not sure why I'm seeing this. Okay, so now we're seeing the sine wave of one of them, so let's try to see the sine wave of the other. Why is it showing up a different color? You can see the ups and downs of the individual MOSFETs. At least on phase 1. I don't know why phase 2 is showing up differently. I don't know how to correct that, but it is a sine wave. It does look good, but let's go ahead and put a load on there and see what happens with the load. Let's try the shop vac. Alright, so here's with the shop vac and without the shop vac. That wraps up my test of the inverter on the LV5048 model. Now it can do the resistive loads and it can do some surge capacity, but I was really disappointed that it couldn't handle a miter saw. And I regret that I don't have more time. I couldn't hook up some solar panels to this to test the MPP input, because this particular model is also a dual input Mppt, maximum power point tracking, solar charge controller. So you can hook up 2 separate strings up to 150 volts each, or maybe it's 145 volts each, and you can charge your battery with that. So that's really cool, but I'm sorry, I just ran out of time. I only have this for one day to be able to test it. So I hope that helps some of you in your buying decision. I love running tools, so I'm gonna have to stick with the low frequency inverters that have big transformers in them. And now I'm really worried about whether or not this is gonna be able to power my buddy's well pump, because that is the whole purpose that he went with this one. Now his well pump, is using both phases, so hopefully that helps. Now remember, MPP Solar is not sponsoring this video. My buddy bought this at full price. It's not special because of the YouTube channel, and he's just letting me borrow it for a day to test it out and make a video for you guys. So I hope that review helps some of you in your buying decision. If you like the review, please like, subscribe, comment, share. You can check out some of the links in the description below. I'll link some of the things that I've used in this video.